Hey, so for the last section of this video, lesson 3.5, properties of rotations. We talked about properties of translations, of reflections, and finally we're going to talk about properties of rotations. Dilations will be addressed in a different unit in our triangle similarity unit. Okay, so again, this is the last video and I'll try to make it as quick as possible. Okay, so as we know, a rotation is a turn. And like we discussed in the previous videos, what are the properties that apply to rotations? I'm going to move this in a little bit so that you can see. Okay. So moving that over, getting it in focus. Corresponding segments and angles on the pre-image and image are congruent. So the same with rotations, reflections, and translations, okay? And that's why they're called congruent transformations, okay? This is the reason why, because that property under a rigid motion, isometry, congruence, transformation is preserved. So again, angle C is congruent to C prime, angle B is congruent to B prime, angle A is congruent to A prime. Side AB prime is congruent to side AB. Side BC prime is congruent to side BC. And, side A prime C prime is congruent to side AC. Okay? And we see that here in the example. So just make sure you make a note of that example. Points move different distances. Distance traveled depends on the distance from the center of rotation, which means that A prime A, the length of that, B prime B, the length of that, and C prime C, the length of that are all different values. So it's only with a translation that they're all the same value or that they're equal, okay? So and we can see that in this example here. Okay, so A prime is not the same length as B prime, and neither is C prime. They're all three different lengths. Special points. Okay, so the center of rotation, which in this case is O, all right, that's the center of rotation, is the only point that remains unchanged. So kind of like that same thing with that invariant, those invariant points and reflections. If the center of rotation is O, then O prime and O remain in the same place. Doesn't change, okay? That center of rotation stays where it is. All right, it doesn't move, okay? And then finally, the orientation. So the orientation, meaning the order of the points, the pre-image and the image have the same orientation. And let's test that out. So again, I want to read these points clockwise. So if I go around, we know the hands of a clock go that way. A prime, B prime, C prime. Again, with this with the pre-image, A prime, B prime, C prime. I read it clockwise, and the points were in the same order. Okay. Now let's try counterclockwise. A, C, B. Counterclockwise on the image. A prime, C prime, B prime. So for a translation and a rotation, the order of the points is preserved. The orientation is preserved. Only for a reflection is the orientation of the points not preserved. Okay? All right, so let's go ahead and do the try it out. We're going to do that together. And then in class, hopefully when we review it, or we review something similar to it, this will help to clarify some things for you. So it says here, quadrilateral ABCD is graphed on the axes to the right. When ABCD is rotated 90 degrees in a counterclockwise direction about the origin, its image is quadrilateral A prime, B prime, C prime, D prime. Is distance preserved under this rotation? And which coordinates are correct for the given vertex? All right, so is distance preserved? What does it mean when we say is distance preserved? What does that mean? All right. So the first thing I'm going to do actually is do the rotation. All right. So A is 1, 2, 1, 2, 3, 4, 5, 6, 2, 6. B is 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3. C is 1, 2, -1, and D is 1, 2, 3, 4, -4. And I'm sorry, A was -2, my bad. 1, 2, 3, 4, 1, 2. All right, so -2, 6, 4, 3, 2, -1, and -4, 1, 2. So now I'm going to rotate this image, and like I always say, when you're doing the rotation, literally turn the grid around, rotate the grid, and then reread the grid and plot the points that are here. So because I'm going counterclockwise, I want to turn it to the left. So I'm going to take this grid and I'm going to turn it once, one turn, 90 degrees is one turn, to the left. So that now, from the way I'm looking at it, this is going to be your y-axis, and that's your x, okay? So I just changed it, and so now let's go ahead and plot those points. We're going to find -2, 6, 1, 2, 1, 2, 3, 4, 5, 6. That's going to be A prime. 4, 3, 1, 2, 3, 4, 1, 2, 3. That's B prime. And -2, I'm sorry, 2, -1, 1, 2, -1. That's going to be C prime. And -4, 1, 2, 3, 4, 1, 2. And that's going to be D prime. And then I'm going to connect those up. All right. Looks a little off because I had to go off the grid, but it's fine. Alrighty, so I'm going to turn this back around. And feels like a lot of steps, but it's fine. And then I'm going to write down the coordinates, okay? So A, based on the original graph, right, once I turn it back into position, the original, right, grid position. Now from there, I'm going to read my coordinates, 1, 2, 3. 1, 2, 3, 4, 5, 6. So it's going to be 6, 2. B is 1, 2, 3. 1, 2, 3, 4. So 3, -4. C prime, 1, -2. And D prime, 1, 2, 2, 1, 2, 3, 4, 2, 4. Okay, so, and looking at this, it says, is distance preserved under this rotation, and which coordinates are correct for the given vertex? Okay, so is distance preserved? Well, let's go back to our notes. One property of a rotation is that corresponding segments and angles on the pre-image and the image are congruent. So, yes, distance, side length and distance are the same thing. They're always testing that. So we're going to have to make sure that we remember that distance is that we, know that distance and side length or length is the same thing, okay? So is distance preserved, or is length or the length of sides preserved under this rotation? Yes, it is. So we know that our answer is going to be either B or D, okay? And so for A prime, the answer choices are 6, 2, which is what we got here. And for B prime, 3, negative 4. Well, we know that B prime is going to be 3, 4, or 3, negative 4, not negative 3, 4, so that's not right. So your answer choice is going to be yes, and that A prime is 6, 2.